Hi, I'm Dr. Elizabeth Seng from the Health Research Council for Division 38, which is the Health Psychology Division of the American Psychological Association. Today we're talking with Dr. Jamie Rhudy, who's an Associate Professor of Psychology at the University of Tulsa and the Director of the Psychophysiology Laboratory for Affective Neuroscience. Dr. Rhudy, thank you so much for being with us today.
Thanks for inviting me.
Appreciate it. So you're a psychologist.
I am.
This is the American Psychological Association.
It is.
You study pain.
Yeah.
Why is a psychologist studying pain?
Well, actually I can think of no better thing for a psychologist to study. I mean, pain by definition is a psychological experience. It's our experience of threats to our body, and that perception is what makes it pain. And psychologists have a lot to offer in terms of understanding the mind-body connection that contributes to pain and pain experience, but not just pain experience, but regulation of pain and the factors that might contribute to chronic pain.
All right, so kind of what makes pain better, what makes pain worse,
Yes.
and when somebody has an injury, why they sometimes still feel pain.
Absolutely, and why there's so many individual differences, right? So the same injury in one person might be experienced as hardly anything at all. The same injury in another person might be experienced as the worst possible thing imaginable. And even within a person, right? On one day you might experience as very painful, same injury, another day might be experienced as hardly painful at all. So the question is really what contributes to those individual differences, and how we as psychologists can help sort of harness those regulatory mechanisms to help people cope better with pain.
Okay. So how do the brain and the spinal cord contribute to that painful experience that you were talking about?
So so what we talk about as nociceptive pain, so that just means pain when you encounter a painful event, right? You step your toe, you step on a tack, you touch a hot stove, that's considered nociceptive pain. When you experience nociceptive pain, that triggers the signal to be conveyed from wherever it happened, like say your hand, to your spinal cord, and then your spinal cord then will elicit responses in that limb. So for example, if you touch a hot stove, the first thing that happens not is ouch, that hurts, but the first thing is I withdraw my hand from the actual hot stove. So there's that. So the spinal cord contributes to that response. But then the spinal cord also relays that information up to the brain, and then the brain is where it gets processed and perceived as a painful event. Your brain tells you where it happens, where is it my hand, is it my foot? And it also tells you how intense it is it really bad, or is it just so-so? And then it also helps motivate you to avoid that same thing in the future. And it helps you learn about experiences that are painful so that you can be a more adaptive organism.
All right,
Yeah.
so your brain is really kind of taking the things that happen to you and trying to figure out how to avoid that in the future.
Yes.
Or make it better in the future.
And it's the part of your body that actually tells you that is pretty unpleasant, right? So your spinal cord will elicit those reflexes to keep you from doing it or from continuing to touch it, but it's the brain that says, ouch, that's really unpleasant, I don't want that to happen again.
Okay. Yeah. Now, you study emotional modulation of pain. What is that?
Okay, so emotions, we can think about emotions more globally as these subjective experiences that come from the neural signaling associated with things that are pleasant or unpleasant. Now that's sort of a circular argument, but if you imagine, evolutionarily speaking, right, over thousands and thousands of years, we as organisms we seek out things that are good for us and promote survival, like food and mates and affiliation that help us survive threatening events. And help our bodies be nourished. And we avoid things that are harmful to us, right? Threats, predators, injuries. And so systems have evolved in our brain that help us detect these and process these types of events that are either pleasurable or unpleasurable. So emotions is the conscious awareness of the activation of these systems that help us seek out things that help us survive and avoid things that are threatening to us. And so emotions are those pleasant and unpleasant experiences that we have as a result of seeking out pleasurable things or experiencing threatening things. So by definition, since pain is one of those things that we try to avoid and it's threatening to us, then pain elicits an emotional experience, right? So it's unpleasant. If it wasn't unpleasant, we wouldn't want to avoid it, and we'd probably just be like, okay, that sort of sucks, but I can live with it.
Kind of by definition, because we don't like it, it has this emotional component.
Exactly. It has this we call it a hedonic tone, right? So it's either pleasant or unpleasant. And so partly, pain by definition elicits an emotional response. So pain and emotions are integrally tied. You can't sort of uncouple them. But in addition, painful events that are experienced in the context of another emotional event triggers processes that allow us to regulate pain. And so it would make sense if you think about, again, evolutionarily, if things that are important to our survival, like food and mates and affiliation, these things that we need in order to survive, you wouldn't want pain-like responses to get in the way of us seeking out and actually obtaining these things. And so in the context of these pleasurable events, pain is often dampened. And similarly, you can imagine situations where, say, our ancestors were in the woods, or even us, in the woods, and there's a sense that there's a threat going on, something that may be there, maybe you hear a rustling in the woods, or some leaves cracking, or twigs, and so maybe there's something out there that's threatening. And in that situation, you're probably likely to feel something like anxiety, or starting to feel fear. And in those situations, it's adaptive to heighten your sensations of potential painful events so that you can detect them quickly and respond to them. And so what we know is that these unpleasant emotions in general, tend to enhance painful experiences, and pleasant emotions tend to dampen them. And so because the emotion and pain systems seem to be so integrally tied in this way, then as psychologists, it seems important to study the ways in which emotions can regulate pain, because it's like we are able, using emotions, we can tap into these systems that allow us to turn pain up or down, and obviously that can be adaptive in some circumstances to be able to turn pain down or avoid heightening pain.
Sure. So there are situations that make it easier for us to feel pain, and there are situations that make it harder for us to feel pain, and a lot of these situations are emotional.
Yes, yes.
They're emotional in nature.
Yes.
Okay. So how do you study emotional modulation of pain? What does your research actually look like?
For participants who come in for the first time, they probably have a very weird experience because we do elicit pain in the laboratory. And we, in particular, since we're interested in the spinal response, so we actually study that reflex I talked about, where if you touch a hot stove and you respond, right? So that reflex can be measured using something called EMG, or electromyogram, that allows us to characterize and quantify the size of the reflex. And the size of the reflex is important because you might imagine touching a hot stove and having a pretty big reflex, but if it was a really searing hot stove, the reflex would be even bigger. So the idea is that bigger reflexes indicate bigger spinal cord, because the spinal reflex is actually responding to that painful event more vigorously. In fact, it's actually saying ouch, even though your spinal cord can't actually say ouch, that's your brain. So since we're interested in this reflex that occurs in your leg, like stepping on a tack, we measure muscle activity in the back of the leg, and we actually deliver electrical stimulations to the ankle. Most of the time, that's what our designs look like. Now, we use electrical stimulation so that we can record specific response, but we also do all kinds of other things. We do cold pain, so we oftentimes will ask people to put their arm in very painfully cold water and see how long they can leave it in there. We use something called a heat thermode. That's something you put on contact with the skin, and there's a device that can heat it up and cool it down in a safe way so that you can precisely control the temperature. We do things like ischemia, where you inflate a blood pressure cuff around the arm, and then you occlude blood flow to the arm and the muscles, and then you start to get this aching sort of gnawing sensation like musculoskeletal pain. There's pressure pain, where you can take this little device and press it on certain areas of the body and measure the pressure that takes to elicit a painful response in individuals. So these are the types of things we use to measure pain.
Okay.
And then if we're interested in manipulating people's emotional states, what we use is a series of slides that have emotional content. And so our participants will be sitting there watching kind of a slideshow, and then throughout the slideshow we'll deliver electrical stimulations over the cerebral nerve in the ankle, and then we can see whether or not the perceived pain and then this reflex we're interested in actually co-vary with the emotions that are elicited by the picture show.
How do you know that those pictures are going to elicit the kinds of emotions you expect?
Yeah, well, we try it, a couple of ways. One is we actually ask them to rate them, so we get their subjective appraisal of it. But we also pick slides that sort of have a more evolutionarily importance to us as humans, right? So the slides or the pictures that we find actually elicit the most pain regulation are pictures of painful events, right? People who are undergoing, who have had injuries or, their finger mutilated in some way or cuts, and those types of pictures are very, they give you a visceral sensation and they're very unpleasant to look at, and those are the slides that tend to enhance our painful experience when we deliver these electric stimulations. And then the slides that seem to inhibit pain the best are the ones that engage, that involve humans engaging in sexual acts. So I said one of the things that as we've evolved, that you try to inhibit pain during experiences that are important for survival, like copulation. And so it would make sense that during copulation that you might inhibit painful responses so that you can be successful. So turns out that slides do a pretty good, of people engaging in sexual acts do a pretty good job of inhibiting not only the perception of pain, but also our physiological responses to pain.
So in your research, you mentioned that pain occurs at high rates in certain people with different types of disorders, like major depressive disorder, insomnia. What does your research show about emotional modulation of pain in those groups?
Yeah, so we've studied several different clinical populations, but three in particular that seem to be important are major depression, folks with sleep disorders like insomnia, and then we've studied chronic pain population, fibromyalgia. And sort of stepping through each one of those individually, there's a bidirectional relationship between major depression and chronic pain, such that folks with chronic pain are at higher risk for later development of major depression, and folks with major depression are more likely to later go on to develop chronic pain. And with insomnia, or sleep disturbance more generally, we know that that also places you at increased risk for development of chronic pain. And some of the most convincing evidence has shown that if you actually disturb someone's sleep in the laboratory, that those folks are more likely to experience spontaneous pain the next day. And then if you test their pain using experimental methods, they show enhanced reactivity to these painful stimuli. And so it suggests that you can actually enhance someone's painful experiences just by disrupting their sleep.
So if you really don't like your roommate, you can just wake them up,
exactly,
and then they'll have more pain the next day.
Exactly. There
Okay.
you go. It's the best way to get back at them. So, and then with fibromyalgia, these folks have chronic pain. It's very persistent. It's widespread all over their body in all four quadrants. And what we found in all three of those populations is that they fail to emotionally modulate pain, even though they don't fail, or they are able to emotionally modulate the pain signal of the spinal cord. So it seems like as the signal is reaching the spinal cord, they can emotionally modulate it there, so pleasant things inhibit and unpleasant things enhance the signal of the spinal cord. But once that signal reaches the brain, they're unable to emotionally modulate it at that point. So it's like there's something going on at the brain level that seems to make them incapable of turning the signal up or down. So what we're thinking is that this might be a marker for chronic pain risk, since we see it in all three of these populations. And so the next step is really to measure emotional modulation in people who are pain-free, and then follow them over time to see if the folks who are unable to regulate pain before they go on to develop chronic pain are the ones who actually end up developing chronic pain in the future. So we might be able to use it as sort of an assessment procedure to try to predict those folks who might go on to develop chronic pain.
Okay, so you're trying to find the people who might be at risk
Yes.
for more long-term disabling pain conditions.
Exactly.
Okay.
We might be able to catch them early and maybe intervene.
All right.
Yeah.
That sounds great. Thank you so much, Dr.
Sure.
Rhudy, for your time.
My pleasure.
And thank you, everybody, for watching this conversation with Dr. Rhudy and seeing all of the interesting research that's going on with the American Psychological Association's Division 38, or Health Psychology Division.